Okay, so similar shapes. What in the world are similar shapes? Last time we talked about congruent shapes. Let me give you the basic story, and then we'll dive into the details. Um, Congruent, here, let me write it up here. I don't know where to write it. So similar, right over here. Congruent, which is what we did last time. Congruent means identical. Congruent is identical. All sides are equal. All angles are equal. Whereas similar, that just means same shape, different sizes. So similar, today's topic, they're going to have the same shape, but they're different sizes. They're not identical. That was last time. Congruent means identical. Everything's the same. But similar just means, like it says, they're similar. They're the same shape, but they're different sizes. Like these two right here, right? One's a smaller version and one's a bigger version. They look like they're the exact same shape. They are the same shape, but one's a little tinier than the other. One's a little bigger, right? This is the big one. This is the small one. Those are similar. These triangles are similar. Now, what does it mean when they're similar? All the angles are equal. Sides are not equal. So the angles are equal, but the sides are not. That's what it means for two triangles to be similar. The angles are equal, but the sides are not. Now the sides are proportional. We'll get into that in a little bit later by the end of our time on questions 6 and 7. But for now, let's just say similar shapes are the exact same shape. They're different sizes. That's why their sides are not equal, because they're different sizes, right? This one's sides are smaller than this one, but the angles are all equal. The opening right there and the opening right here and the opening right there is the same as those three openings. So for similar shapes, they have all their angles are equal. They're the same shape, but they're different sizes. That's different than what we did last time, which was congruence. We proved triangles are congruent. And remember how we did that? We had all those 3-letter combos, right? We had like angle, side angle, side angle, side, 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 things like that. That's how we proved that two triangles were congruent, identical. But today we're proving that shapes are similar, which means they have all the angles are equal, even though their sides are not equal. All their angles are the same. They're the same shape, but they're different sizes. One's a small version, one's a big version of the same thing. All of this is in the notes. Here's the exam. This is the, the exam 2 notes. There's congruence. We talked about that last time. Angle, side, angle, and side, 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 all that stuff. Well, and then, that means they're identical. Again, there's, congruence means identical, but then here is similar triangles. Let me move over where I can write on. I got it right here for us. Bring it on down right there. So right here, what are similar triangles? The same thing I just said. Similar triangles are triangles whose corresponding angles are equal. The angles are equal, but the sides they're proportional, not necessarily equal. So here is a small version and a big version. See how those two triangles are similar? See how their angles are the same? 30, 30, 120, 30, 30, 120. So they have the same 3 angles. Angles are equal, but the sides are not equal. See how the sides are 3, 3, 6, and this is 12, 12, 24. Notice these are all 4 times as big, right? 3 times 4 is 12, and 6 times 4 is 24. See how the triangle on the right is 4 times as big? It doesn't look 4 times as big, does it? It looks about twice as big. But anyway, they're saying it's 4 times as big. So the sides are not equal, but the angles are for similar triangles. These are the same kind of shape, but different sizes. Similar triangles. And same thing here, right? These two triangles are certainly not identical. They're not the same. One of them doesn't fit right on the other one. They're not identical, but they're the same shape, just different sizes. So that's similar triangle, same shape, same exact shape, but one's a larger version than the other. The other's a smaller version. All right. So let's do it on question number 1 here. So see how this is 98 and this is 98. They've got to be the same because, well, they're saying if the triangles are similar, then what is angle X? What should angle X be if those two triangles are similar? Well, it should be 49, right? If those two triangles are really similar, right? They're telling us if. They're not guaranteeing they're similar. They're saying if the triangles are similar, then what is angle X? Well, it would have to be 49 because remember, similar triangles have to have all their angles equal. So it would have to be 49. Well, what is angle X actually? They're asking us down here, so the actual measure of angle X, well, what do you mean? How do I actually find angle X? Do you see what I can do with this triangle right here to find out what X actually is? What can I do there?
So you would add 98 and 33 and subtract it by 180.
Beautiful. Right on, Martine. Yeah. Yeah, subtract from 180, huh? Because we know every triangle holds 180. We've been using that one a lot. Exactly. So subtract from 180, whatever that is. Let me use my calculator. Oh, I know this. It comes out 49. So it indeed is 49 degrees. And then this one's got to be 33. So look at that. Are these two triangles? So their final question, are these two triangles similar? Yes, indeed. They are because all three angles are equal. The corresponding angles are equal. Does that make sense? So it's 98, 49, 33, 98, 49, 33. They are the same three angles. So yes, indeed, those triangles are similar.